This example says solve the system and interpret the results, and we're going to talk about what this means in a second. But remember, we still have our three ways for solving solutions: graphing, substitution, and linear combinations. Honestly, I don't usually graph unless I see a reason to graph. So I'm going to show you how we can solve this with both linear substitution and linear combinations and show you what the results look like. The reason I'm kind of thinking right now is substitution is because we have this y here all by itself. And remember, we've talked in the past about if you have a y or an x by itself, it's easy to solve for. All we'd have to do is go add a 3x to each side. This cancels out, and I'm left with y equals 12 plus 3x. And then what I can do is I can just substitute that right in here for y. So I'm going to have 6x minus 2 times y, but we know now y equals 12 plus 3x, and then equals 10. Keep, change, change. If we simplify this, we have 6x plus negative 2 times 12 is a negative 24, and I'm just going to put that in parentheses for neatness, plus negative 2 times a negative 3x, I'm sorry, negative 2 times a positive 3x is going to be a negative 6x, and that equals 10. Our like terms, look here. 6x's and negative 6x's ends up being 0x's. 0x's plus our negative 24. Basically, this means that negative 24 equals 10. That is not a true statement. So if you think back to what happens when you get a solution that doesn't make any sense, this can never be true. Negative 24 is never going to be 10. We know that there would be no solutions. You kind of have three choices. You have one solution, you have no solutions, or you have infinitely many solutions. One solution is when you can get an x value and a y value. No solutions is this, when you come up with an untrue statement. And infinitely many solutions means that actually every x and y value in a solution set on a line in a graph make both of these equations true. So if you chose to solve this with substitution, this is what would happen, and you could write no solutions. But remember, sometimes you might default to linear combinations. Now, with linear combinations, remember, you have to get something to cancel out. And so what I might do in this one is multiply the second equation here by 2. And the reason I would do that is because if I was looking at my x's, I know that would make them cancel out. Or even if I was looking at my y's, that would make them cancel out. So basically, we get 6x, and I'm going to write it as plus a negative 2. Negative 2y equals 10. And if I multiply by 2, I get 2 times a negative 3x, which is going to be a negative 6x, and 2 times y, which is going to be 2y, and then 2 times 12, which is going to be 24. This is the linear combination method, so we add them together. These cancel out, I'm left with 0x's. Well, these cancel out, so I'm left with 0. And over here, I get 10 plus 24, which is 34. Basically, 0 equals 34, which we know not to be true. So again, when it talks about interpreting the result, that's what we did right here. There are no solutions. This linear system right here has no solutions. And that's what they mean by interpret the results. This is our results. It means they have no solutions because 0 cannot equal 34. Okay. So using any of the methods, and I gave you an example here of the substitution method and linear combination method, it doesn't matter the method. Those are just 3 different ways, including graphing, where we can solve linear systems. It doesn't matter the method. Your results are going to always be the same.